See, in this question, like it is mentioned that there's a circle that touches both the coordinate axis, x-axis and y-axis like this, and now and also touching this line. Now, if you look at this line, there is a variable component in this line. So because of this variable component, it is not a fixed line. It can be anywhere. Now because alpha can take different values, so this line can move to any of the four quadrants. Now because of this, because alpha is there, because of which this line can go to any of the four quadrants, we'll have to consider four cases in this. Because circle touching coordinate axis can lie in any of the four quadrants, right? So and this line alpha, we have no idea about alpha, so this line can show presence in any of the four quadrants, like this. So in this question we'll have to check all these four cases. The case where center lies in first quadrant, we take radius r comma r and find distance of the center whose coordinates are r comma r from this tangent line and equate this distance equals to r. In this case we assume center as r comma minus r comma r, taking r positive, taking r radius, that is positive, minus r comma r, find distance from this tangent line, equal to radius. And same we do here, center minus r minus r, r minus r. So I'll just show you how to find equation of circle by taking first one case, that is circle lying in first quadrant. I'll take the example of first quadrant, and other three you can do yourself. Now instead of taking like radius r, I'm taking radius equal to g, because that is what has been taken in the question. If you just look at the choices, instead of r, g has been used, so I'm using the same g. Now as circle is touching both the coordinate axes, center of the circle is g comma g, right? So and now we'll find distance of the center from this tangent line and equate it to radius, that is again g. So using distance formula, distance of g comma g from this line equals to g. So we get this using distance formula. Now you can see there is a mod sign, and this mod sign means we'll have two cases, and this two cases corresponds to two circles. See, we can have two circles touching coordinate axis and touching this line. One is the inscribed circle like this, inscribed in the triangle formed by coordinate axis and this tangent line. Other circle is a scribed circle. See, the scribed circle is also touching coordinate axis and this tangent line. But in this question we are not, like in this, it's not mentioned in the question. I think choices have been made based on circle inscribed in the triangle, so otherwise they should have been mod in the choices. So let's solve this question, because choices are matching like as if we have to find inscribed circle, not ascribed one. So two cases we can get from this side. We're rejecting one case, and the case we're rejecting is the case of the ascribed circle, though it should have been mentioned in the question, which is not given, right? So I think the choices and the answer is done using that as if we have to find the inscribed circle. So let's focus on the inscribed circle. Now to find the inscribed circle, we have to reject the inscribed circle. Means we have, because if I remove this mod sign, I get plus minus here. So we need to decide which sign is representing inscribed case and which sign is representing inscribed case. To decide which sign to take for inscribed case, using the expression of the line, using equation of the line, we make this expression. This is nothing but expression of the line. Now if I see the sign of the 0, 0 with respect to this line, I'm using the topic position of point with respect to a line. Sign of 0, 0 with respect to this line, we replace x equal to 0, y equal to 0, we get negative. So sign of origin is negative with respect to this line. Sign of origin is negative with respect to this line. So it means this side is the negative side of this line, and the opposite side is a positive side. Now for inscribed circle, you can see the difference between inscribed and ascribed is inscribed and origin center of the inscribed circle and origin lie on the same side of this line, whereas origin and center of the inscribed circle, they lie on opposite sides of this line, right? So we want that case whose sign with respect to this line, position with respect to this line, should be same as that of origin, because we want inscribed case. The circle whose position should be on the origin side, that is what we want, because we want inscribed case. So position, the circle, not this circle whose position of center should be same as that of origin, that is towards origin. The sign of origin is negative, we replace g comma g. Now g comma g, after replacing g comma g, we get this. Now if this point has to lie on origin side, then sign of this expression should be negative, because sign of origin is negative, and sign of this expression is negative means this part is negative, this part is negative. If this part is negative, right hand side should be negative. For otherwise, how can the two sides be equal? So we get g cos alpha plus g sin alpha minus 2 equals to minus g. So we get g cos alpha plus sin alpha plus 1 equals to 2. G equals to 2 divided by and circle is center is g comma g and radius is also g. So for this circle, for like g should take this value, and if you look at that, this will become x square plus y square minus 2gx minus 2gy plus g square equal to 0, and that is first choice, a choice. Similarly, you can do yourself and you can figure out all three choices, all four choices are correct in this question. But let me repeat this question. In this question we have assumed that we have to find circle that is inscribed inside this triangle formed by coordinate axis and this tangent line. We are not taking the ascribed case. Or maybe the question mentions that it can be. So this circle is matching. We are finding only one circle. We are only finding one circle. But if we don't take this inscribed case, then we'll have another circle for ascribed case. So we are not finding that equation. So if it is not mentioned that circle should be inscribed, that is also fine, because if there can be two circles, inscribed and ascribed, we have found this ascribed circle. If you find ascribed circle, it is not going to match with any of the choices, so there's no point finding ascribed circle.